And thank you to World Steel for giving us the possibility also to bring into a German view on the discussion on circularity, which is of course not completely different with the one we heard today from Axel Eckert, and which is represented by Eurofair. Nevertheless, I will try to keep replications to a minimum, and I in particular will not touch the issue of CO2 reduction, although I know, of course, that this is a very important part in the debate. If we talk about a German view on a circular economy, I think we have to start with at least two stylized facts. The first stylized fact is that Germany, as you all know, is a highly industrialized country, and if we look into the current forecast, we believe that it's going to stay like this. Forecast of Prognos, which is the leading research institute in Germany on these long-term horizons we have, they forecast a growth rate of 1.2%, and the important point to note is that the manufacturing sector is expected to grow with the same rate. So therefore Germany is expected to keep this very high share of industry at GDP, which really makes Germany distinguished from the other G7 countries who have or have much lower shares. But the particular thing is not only that we have a high share of manufacturing sector, but that the manufacturing sector in Germany is extremely steel intensive. It's not only the construction sector, it's not only the automotive sector, but in particular also the very strong sector for steel and metal producing, which consists in particular of medium-sized companies, and also the structure, I think, has imposes a particular challenge when we later on talk about circular economy effects. I think also an important point to note is that in Germany, or in the steel value-added chains we have in Germany, the relationship between steel users and steel producing companies is not only focused on deliveries, but there are also strong networks where steel users and steel companies together try to innovate new products. Now, the second aspect of Germany is that we have, or are confronted as an industry with very ambitious environmental and climate goals. We have this morning already talked about the 2050 vision of the European Union. In Germany, we in addition have goals for 2030. We have in addition also goals for the share of renewable energies, and also for energy efficiency. And I think as a general line, we as a steel industry in Germany, we have to accept that the mood of the country, the sentiment of the country is always like to do a little bit more than in Europe, to be a front runner, not only in the world, but also in Europe. And we support this also because this is expression of the demands of the society. And confronted with these two challenges, keeping international competitive in the industry as a whole on the one hand, and also being confronted with very demanding climate and environmental goals, circular economy is very important. We regard it as the most important instrument to reconcile these two objectives, and there exists in a very known important study of McKinsey, who has shown that it's possible to do this. We have seen some of these results already in the presentation of Mr. Potocznik. The basic point is here, it's possible to have further GDP growth coupled with an enormous progress in resource efficiency, and even more so with respect to CO2 emissions. McKinsey also made the point that Germany actually is in a very, very good position to capture many of the gains associated with implementing circular economy principles, just because so many German companies are technological leaders in the technologies used for implementing circular economy. I think it was also very important that McKinsey made clear by a number of examples how far away Germany and the European Union is at the moment from being a circular economy. It's highly linear. And this contrasts, in my view, to the picture we have when we work in the steel industry and look into the steel production processes. We have already talked a lot about the circularity in the steel sector today. we sum it up in my associations always by these 5 points. Steel production, yes, it is resource intensive, but enormous progress has been made. We have almost complete use of byproducts. Steel is, as we have heard today many times, a leading example of recyclability. Is a permanent material, and it's also a key enabler of improvement in the downstream sectors. And I will argue that the first 4 points are already highly optimized, and that the great potential of the steel industry to further contribute to a circular economy lies in the 5th point. So I just give you the basic facts for the numbers for the German steel industries for each of these 5 points. You see here the enormous gains we have made, or the companies have made, in the steel industry during the 1980s in terms of resource efficiency, the strong gains in terms of raw material. Iron ore, coke have fallen by 43%, water by almost 80%. You see the progress that has been made with respect to energy efficiency, and enormous progress has also been made with respect to dust emissions. I think just by looking at the curves, it is relatively clear that the low-hanging fruits have already been picked, and that the processes are already to a highly extent optimized. Talking about byproducts, in particular slag is the most important one. I learned in preparing this conference that byproducts are not only used, but that they are really part of the production process, that in the production process of steel is already included the plans for quantity and quality of byproducts, and because of this, byproducts in Germany play also an important part in the value-added chains. You see on the left-hand side where slag to the sectors where slag goes. All in all, it's 14 million tons. Landfill is kept to a minimum. It's around 6%. Maybe there could be done more in this respect, but this would also need the support of better political regulations. We have a special issue in Germany in this field, which prevents that the true circular economy potential of the steel industry here is fully exploited. Germany is a scrap collecting country. We have 3,500 sorting plants in Germany. Basically everywhere in Germany is a sorting plants, which helps to really to achieve a very high recycling rate, which is, for example, for the steel packaging, almost 90% or even higher than 19%. There's also strong industrial networks which lead to a large amount of new scrap, which can be collected almost to 100%. So therefore recycling in Germany is really at a high level, and it's difficult to further really get a more circular economy gains. And the environmental balance of Germany is, or of steel in general, is strongly improving if we look into the multi-recyclability of steel. We heard the word of multi-recyclability already in this conference a couple of times. What you see here is a study of the Technical University in Berlin, which basically states that steel can endlessly be recycled without any loss of inherent qualities. It can be, there will be no downcycling, at least theoretically, and also in the second and third generation you can produce and also have the same amount of innovation in steel. Now what you here see is over a time period of 100 years, taking into account that the lifespan of a steel product is around 15 years on average, that over a time span of 100 years the footprint of steel improves by 40%. What I have shown you are the 4 key characteristics of steel as a circular material, where I think there is not so much potential, but there may be a lot of potential if we look into steel as an enabler of innovations in downstream industries. We have heard today that steel is responsible for around 30% of all manufacturing emissions. But also, steel products help to save CO2 emissions, and together with Boston Consulting, we looked into this balance in more detail by looking into 8 sectors, and we asked how much steel is needed or how much emissions are generated by the production of steel, and how much emissions can be saved by implementing these innovative steels in the 8 sectors, and the balance was strongly positive. 12 million tons were generated, and 74 million tons could be supported by steel to save CO2 emissions. Now, I think that this is one way to look at it, that a strong potential for the steel industry can be or lies in his role as an enabler. And if we think about digitization, this might be an aspect where the role of steel as an enabler of technological progress in downstream industry could be truly supported. We also have looked into this question in a study which was published last year, the digital transformation of the value-added network steel. On the left-hand side, you see the German title. And there are basically a number of key results of the studies, which you can read here on the right-hand side. I think the most important result first is that steel companies regard digitization as an opportunity, not as a threat. So they do not expect that digital transformation will lead to disruptive effects in the next couple of years. Secondly, steel will become an even more important in the value generation chain through the digital transformation. So what we have done in this study, we asked about 2,000 steel-using industries across all sectors, whether they believe that steel will keep its crucial role in the steel value-added chain as it has today. Will it become more important, or will it become less important? And we got a very positive majority with respect to the hypothesis that steel can keep its crucial role in the value-added chain. And what we also know from the survey results is that all companies are highly investing into digital transformation on the steel company side as well as on the steel user side. Now, we use this study also in order to find a methodology how digitization in the steel industry can support digitization in the downstream sectors. One aspect has to do with that it increases the innovation ability, because companies now, steel users and steel companies can cooperate more closely in the field of research and development, and we have demonstrated this also for the construction sector. Digitization will allow to broaden the product portfolio by offering smarter steel products, and it will lead to an optimization of the value creation process. It will lead to a factor called hybridization, which means the coupling of steel products with certain services. Very important is the aspect of virtualization, that you do not have really to produce prototypes. And this again also will not only save costs, but will shorten the product cycle. What has this all the things to do with circular economy? I think it's very easy to see that all of these things are also powerful drivers of circularity in the value-added chain, because innovation ability, the very close cooperation in research and development between companies and steel users create new possibilities for product design, eco-design, and also will have a very strong and positive impact on recycling. It will be able to provide better products and thus more technical, environmental friendly innovations. It will allow an improvement in material and energy efficiency along the entire value chain, allows the observability of products, in particular predictive maintenance, and this will increase the service life of the products. And virtualization makes the construction and testing of prototypes superfluous, saves material and energy, and leads to faster implementation of circular economy effects. How important are all these effects of digitization in the steel industry, and also, if you may say so, the circular economy principles? We ask a number of questions also in this study. We asked the steel-using companies whether they are integrated into the research, development, and construction process together with the steel industry. We asked what steel-using companies expand their product portfolio by digital steel products. We asked whether they use hybrid services bundles in the steel industry, and also whether they already virtualize products and processes. And the answer, and a lot of more questions, which I do not want to bother you with, but the answers are quite easy to generalize. We always see that the majority is this black part of the circle. That means that it is taking place, but from the majority is not doing it at the moment. The majority is not really at the moment offering hybrid surfaces in the steel industry. So there's a lot of room for potential, which if we see it from a positive side. And we know from the service results that around 30% of the steel using companies we ask believe that these four elements will play a much larger role within a period of 5 years. So I think that the general idea here is to say that there's a lot of room for improvements if we couple digitization with circular economy principles. Concluding, just my basic idea is to say that there are a number of building blocks that are necessary in order to have a successful circular economy in the steel industry. If we look to the left-hand side, to secondary raw materials, to raw material efficiency, energy efficiency, and also to byproducts, the steel industry is already very strong. This makes it also peculiar for building a circular economy. But if we think about driving the process further, reaching further, making further progress, we have probably to look into the right-hand side, to networking by digitization, to material expertise, to looking at product development, customer requirements. I wrote down also a number of conclusions, which I will leave to you to read it in the aftermath of the conference if you are interested, and I thank you very much for your attention.